G'day everyone, welcome back to Harper's Shed. My name's Tim. Now, typically, I'm more of a beer drinker, but this week, we're focusing on the wine. Alright, just before we get into this breakdown, I just want to say a huge thank you to anybody who subscribed. Just ticked over 100, woo, go me. Not, massively impressive numbers, but by the same token, I'm very humbled by anybody who's interested enough to click the subscribe button. So if you're watching this and you want to help me out, I'd be most grateful if you did. Yeah, I mean this is a pretty big project and a pretty big undertaking. So yeah, any help, support, comment, subscribe, like, share, all of that, it's really appreciated. Yeah, as I said, very humbled by anybody who wants to show enough interest or think that I'm doing something interesting enough to want to watch us. Yeah, it's really nice. So anyway, we'll get that out of the way and I'll show you a breakdown of the supercharger. Alright, so just a real quick recap. Obviously the engine's all back together now and coolant seals have been fixed. Everything went back together really well. I didn't do a compression test or anything with it yet because I don't sort of have it set up. Started mocking up all our pulleys, so I was going to modify it and run a serpentine belt for all the accessories, but I think it's just a lot of extra work I don't really need to do. So we're going to be running the factory water pump, factory power steering, factory aircon, all off the standard pulley configuration. Now obviously what's missing here is the alternator used to sit up on top, and it can't. So I've got this, which is a alternator off a Lexus, so it's actually a Toyota part. And I'm going to make a custom bracket for it to sit down on this side, and it'll run a pulley off one of the water pump pulleys. So the back belt that runs the water pump will also come across, and this will be the tensioner for the water pump and the alternator. I think that'll work all right. Now the supercharger's not bolted to the manifold yet, but that's its final location, which actually works really good. If I give you a shot from the side, sorry, excuse the jerkiness, it's lined up pretty good with the front. So I'm going to make a custom pulley. It's going to be, this will be running an 8 PK or an 8 rib multi-rib V-belt with a spring tensioner. Now it'll come back across the snout a little bit. This belt in the background here, if I try and line it up, there's a bit of room there. So this is my power steering belt. So if I come back another, what do we got? Probably back another 2 and then forward another 2. This is a 6 rib pulley, and 2 back, 2 forwards, 4, 4, 6, equals something. It will come down, and the front pulley I make, it's going to be pretty good. So I'm not going to have to shorten this snout. Now originally I thought I was going to have to, just based on the location of the engine bay, but I don't think I'm going to have to. And I'm pretty happy about that, because that's a fair bit of dicking around. It's a lot of work. If I don't have to do it, I don't have to do it. And that's about where we're up to. Nothing else has changed. This is all loosely bolted, nothing's sealed up or anything. Front cover's on and sealed, and so's the sump, and the engine itself is closed. So it's all just accessories. But like I said, today we're focusing on the blower. So we're going to do our porting. I'm going to strip the rotors off their housing, off the center plate where their bearings are, and I'll show you why in a minute. We're going to machine out our throttle body, make it bigger, and then make a new butterfly plate for it. That way this thing can stand some chance of pulling enough air to feed the monster. So let me get that supercharger off, strip down, and I'll show you what we're working with. Alright, so this is the breakdown, and this is what we'll be working on. Not so much the elbow, although we'll get just some internal porting, open it up, clean it, standard blah 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 stuff. Something I do need to work on that is specific for my application is, because I am running so close to the firewall, which I need to notch anyway, what I'm going to do is I'm going to machine some thickness off this flange here and this flange here, and what that's going to do is have a direct effect on moving this elbow forward, and that's going to help me. Every millimeter I can get off the firewall is going to be good. So I can probably pull 4 or 5 mil off that side, 4 or 5 mil off that one, and that's just going to get me that little bit further away from the firewall. I'm still going to have to notch it, but if I don't have to take too much out, I won't. Throttle body, maybe not this video, but maybe, we'll see. So this is a factory L67 supercharger or Eton M90 supercharger throttle body. They come out at 63 millimeters in diameter. You can take them out to 70. Now, yes, that's only 7 millimeters. It might not sound like a lot, but keep in mind, you know, when you start talking area of a circle, if you double the diameter, you quadruple the effective area. So a small increase in diameter actually does have quite a large increase in the area and therefore the volume you can put through. Now we get into the meat and potatoes of it. We're going to do some porting on the case, and I'm also going to do some welding as well. I'll show you that. But the main thing I have to do is these rotors come from the factory coated, and as you can see, coating's not as present as it used to be. Now there's a company locally who I haven't talked to them yet, but if they're really nice, might let me film in there and I can show you what it's all about. But they will do a high temperature Teflon coating on these, and these technically run an interference. It's a very slight interference, but they do run it. You get them recoated with a Teflon and then they will bed into one another, and you get a much higher efficiency out of it. It is a little tricky to do in that they're not splined onto these shafts and they have to be timed. So I have done them before. They are a little tricky and they really do take some setting up, but you have to press these gears off. And I can't even remember, it was a long time I did it. I don't even think there's a spline on there at all, but I could be wrong. We'll find out. I'll press it apart and we'll have a look. But they just require really good marking of the teeth and marking on the shaft. And you have to retime them back together essentially exactly right. But that's, you know, that's future Timmy's problem. It will come apart. I'll send it to the coaters and get it done. Not an overly expensive process. It's about 180 bucks, he said. So money well worth it, because these rotors flaking off are no good. And if you pull that coating off, you lose quite a lot of the efficiency of the supercharger. So now this is where we have to start getting back onto the machine. I think I showed in a previous episode, but this bridge has to come out. It's, you know, raised up. When you put an intercooler on it, you want to remove that bridge and run the V in the supercharger, which lines up with the helical nature of the lobes. You want to run that back so that more of the supercharger is exposed to the intercooler, because the air to water plate rather is that big. Not that big. It's actually it's the full size of the base. So you want to remove that so that when the air comes out, it sees the entire surface of the intercooler plate. So we machine that out, machine just that out, flatten it all off. We bring these lines back. Now this edge here is the actual very rear edge of the supercharger, so supercharger port. So we can't come back that far, but we come back to, you know, make it realistic in here somewhere. Now these are what are called silencer ports. Now I don't entirely understand the physics of it, but they let a small amount of air out before the main lobe comes to the discharge port. My understanding is that air creates a turbulence effect which quietens the supercharger down. So it reduces our whining noise. Now, we don't want that. We want this thing loud. It's on a rotary. It's not a, you know, we want it loud. I've seen people use like DevCon, you know, JB Weld, all that sort of stuff to weld to fill them. I'm going to weld it. I really don't think it's going to warp the plate at all. It's a small weld. You know, it doesn't have to be full penetration thickness. It's just got to be, you know, welded properly. I don't think it's going to warp it. So that's what we're going to get on, and hopefully we can get this thing done, strip to the coaters, weld it up, start some porting, definitely get this machined, and yeah, start getting it ready to final assembly on the ancillaries on the rotary as well. So So just as a before and after, so these are silencer ports welded up. I'll come through and clean them up. They're not really sitting proud, they're just a little bit dusty, but so that's how much of the supercharger discharge port is actually open directly to the runners. So we'll set it up in the machine now and take out what we have to, but it'll be quite a lot more. So you'll see these corners here will come all the way back, and the V itself will also be substantially wider. So just a before and after of how much is actually open to the runner. Alright, here's the setup. So took a little test pass here just to make sure everything was all square. Yeah, we're going to machine these lugs out, and then we're going to machine the V out further, and we're going to machine the bridge out the back here like I've already explained. Pretty easy stuff, but I'll set a time lapse up and we'll get it done. Sorry, just noticed that I didn't push record after I moved it. So to get these angles, all I did was just spin it on the table, and you saw me mark it out. I just lined the tool path up with my lines and went through a machine in a straight line. So instead of the case being on the bed like that, it's a little bit dark, but yeah, just moved it so that it's running parallel with the bed. That way I can get a nice machined angle along these edges, and I kept that angle the same as the factory angle that was sitting in here, because that actually has an effect. That's direct relationship to where the lobe starts to discharge the air, because they're, as I said, they're helical. So, but I'll tidy it up and give you a look at it back on the manifold. Alright, so all done. You can see, probably not with that light, you can't. Try it up there. You can see there's a lot more of the intake runners that are open to the bottom of the supercharger. I'm not overly happy. Right back there, that's the secondary port for the rear rotor. Like, let's see if I can point it out. Not with that light. Come on now. Just do as you're told. There we go. So it's all the way back in there. I'm not really happy about that, but there's not much I can do about it. So we'll just have to run it. I will be running individual EGT probes, so I can trim fuel to suit. But anyway, we'll just have to see. I mean, the primary's fine. The primary's, you know, smack bang close to the center, and the front two are going to be no worries. So it'll be a suck it and see. When you do put an intercooler on, these lift up, obviously. So there'll be like a 2-inch intercooler plate going under it, and that gives the air more of a void to spread out. So we'll see. Hopefully it's alright. Alright, so that's all back together. I just sort of gives you a bit better of a representation of the relationship between the angle that we maintained and the lobe of the supercharger. So as you can see, the angle follows the same angle, if you will, as the helical in the supercharger. So it's all for a reason. I will state that this is the largest I've ever taken one out. The previous few that I've done, I didn't go all the way to the edge. I sort of left it in, you know, about there. So, but we'll see. I mean, who knows? Really, if it's no good, I mean, I paid 150 bucks Australian, so like $7 US for this charger. If it's no good, I'll buy another one. They're everywhere over here, so no issue. Alright, let's do something just for the childish nature of it. Means nothing to anybody, but at least it'll give me a good indication, make sure nothing's hitting inside. Let's spin it, see how loud it is. Is that the right way? Yep. Didn't have to, but you know, why not? So now we'll strip it all down, get the rotors out, and I'm going to send them off to get high temperature Teflon coating put on them. Tighten the clearances up and it'll make even more pressure. Alright, so we're going to have to pull, these gears have to get pressed off the shaft. Now, like I said, they have to go back in a particular orientation at a particular time. Time is in a reference of together. Now, these gears are case hardened on the outside. You're never going to mark them. So what I do, because I'll set them better when they go together, is I'll put a pin punch mark there and a pin punch mark there. Now that'll line them up somewhere near it, and then on this one, because I want this one back on this lobe, I'll do 2, and then I'll do 2 matching. That way that gear will go pretty good. That gear will go back on that lobe. These are that hard that I don't even know if I can punch it. I'll give it a go. Let's try. Nope, flatten my pin punch. So they're also in the same plane, which, you know, may or may not mean much. Anyway, so now I've got to get a little gear puller behind it, warm these up a little bit and get them off. Boy, did I underestimate getting these little suckers off. I got one off and it was not easy. None of my 3-claw pullers would actually get behind it. I pull it and I tried just heating it up, not crazy, but just heating it up, and it just, nothing. So I made this cradle that supports all the way around the gear as much as it can, and it attaches to our hydraulic gear puller. Mandrel, arbor, I suppose is what you could call it, and that threads into that unit. And then we've got a socket because, you know, why not? And then good thing about these is you end up with a lot of hydraulic hydraulic effect on top. So there we go. That's it. And then you just wind it through. But I tell you, that might have taken a minute to show, but it took me a little while to knock the tool up. So just sometimes these things, they really do take longer than you want. But I just have to spin that around. So anyway, finished getting these off, and I'll knock the rotors out, and I'm replacing the bearings anyway, so I'm just gonna drive them out of the bearings, and then yeah, we'll get them sent off for coating. So just a closer look at the tool that I made. There's a bit of pipe that I cut, took an edge off, and then welded a plate on the bottom with a relief on it, and the whole lot slips over the gear like that, and the relief goes around the hub on the back, and yeah, it just pushes it. So if you haven't seen one of these before, this is a hydraulic multiplier. Essentially the rod that's in here is packed full of, actually I'm not sure if it's hydraulic fluid or grease, but it's a non-compressible fluid. Should have done my research, but anyway. And what you end up with is, as you run this, you end up with a small piston in here pushing on that, and it gives you a substantial hydraulic advantage, and you wind it in. They're really, really good. You can put a lot of load in a small area with one of them. So anyway, that was a pain in the butt. We'll get the rest of it apart. There we go, all stripped. They're pretty shot. Like, the rotors themselves are in fine condition, but yeah, they're obviously delaminating. So yeah, there's that tool again all pulled apart. there's really not much more I'm going to do to the charger. So, as I said, I've got to machine these flanges back just to try and get me some firewall clearance. And I'm going to ball the throttle body out. And apart from a small amount of port matching, like, that's about it. You know, that... Oh, jeepers. Sorry. So, yeah. That's a fair bit. That's where the majority of the work to be done is. You can get a bit crazy up in there and start moving these. You know, this surface, you can bring it down. But I just, yeah, I really don't think I'm going to go to that extent. I could always do it later. I'm not too worried. But so anyway, as I said, really the throttle body is the only other thing that's going to get any major work. And I'm going to have to wait for the rotors to come back before I can put it back together. It's going to get all new bearings throughout. I'm actually going to order, you can buy a full overhaul kit, which has got the bearings in there, and there's also some high temperature seals in that side. So there's seals there, and they seal the oil from coming through from this side. So this side is where the gears were, and that's actually full of oil. That runs in an oil bath. There's also bearings in the back of the case. If I do replace them, I'll show you a trick for them, because they can be a little bit of a pain, but we'll worry about that when we get to it. And then there's some bearings in the snout to replace too. Go through and freshen it all up. And one of the bigger things one of the bigger wearing items, that little donut ring there. That wears. This one's actually in good condition. It's probably been replaced once in its life. They're pretty hard. They're a hard sort of rubber, and when they wear on the dowels that locate them, they start knocking and carrying on, and they sound atrocious. But that one doesn't look too bad, so they come in the kit. I'll replace it anyway. Yeah, that's about it for this episode. I'm sort of a bit stuck. I've got a fair bit going on at the moment, so time's really starting to clamp down a bit, but still pushing as hard as I can. And I did only today manage to pick up a Holden Astra power steering pump, electric hydraulic power steering pump. So I'm going to revise what I said at the very start of the video, and the power steering pump on the engine is going bye-byes, and that should neaten that up a lot. So we're going to use the electric power steering, and that's really the only change with the front of the engine. Everything else will stay the same. So, all right, as I said, huge thank you to anyone who's subscribed or commented or, you know, shown any sort of support. I greatly appreciate it. If you haven't already and you feel like you want to, please hit the subscribe button. Yeah, my watch time and views are pretty good, but yeah, I think I'm at about 78% is not subscribed people that are viewing. So see if we can get that tipped a bit better. Anyway, thank you very much, and thanks for watching, and we'll catch you on the next one.